Okay, we're in business. Let's see who's here and who's not. I'll just put something on the chat to let everyone know that I'm alive, for those that care. So if you're on, put your name in the chat. Yeah, so I really appreciate those people that are replying to the conversation, but like the register's done off the chat because it was so easy just to reply to conversation. Sorry. Isn't great. I've got a bit of a cough today. Nice. Right, so we've got Warren, we've got Zeran, and we've got Fazan. I mean, that's not a bad start, is it? I hope everyone's well and hope everyone's feeling good. I'm not, but it's not anything drastic, so don't worry about that. But you might hear the odd cough here and there. I mean, don't panic. I'm not going to die. Well, probably. Well, might die. I mean, who knows? No plans to die today. God willing. Anyways, enough banter, enough waffle. First bit of news I've got for you. How have I been? Until literally this morning, awesome. And now I've got sick. So, you know, is what it is. I hope everything's well on your side. I hope everyone's fasting is going well. I'm also inadvertently fasting at the moment because I haven't had any time to have any food at all so far. So it's a busy day, but not as bad as yours. Your fast is harder than mine, and I wouldn't say otherwise. Now, what would I say? First bit of news is something that is in the news at the moment, that year 10s and year 12s are looking to come back some point after June the 1st, okay? So I'm just going to deal with that headline as it is appeared in the news. Nothing has been said by Candy or anything like that. So the year 6s is definitely looking like June the 1st. And they said year 12s and year 10s immediately afterwards, all right? So just be aware of that is a thing. I mean, it's not guaranteed by a long shot. I mean, nobody knows. But, like, just have that start coming into your mind that maybe you will be back a week or two before the end, all right? In fact, I don't know what your last lessons are. I think it was late June. So, you may get a week or two. What will you need to have ready for you? Obviously, all the work that you've sent. Hope you've kept it together to have a look at. I mean, I'm not going to take them in because otherwise I'll have, like, a shelf full of your stuff. But it'd be nice to just make sure you've got everything that's sorted. Just be ready that this might be a thing, okay? That's heads up. That's number one. Number two, there is a YouTube video that I've made for you guys on the subject of last lesson's work, because some people did come in contact with me and said, like, Vijay, I don't really get this, or at least I don't get some of this. So I've made another video for you somewhere on my channel. It's called Year 12 Recap or Year 12 Follow-Up or something like that on coordinate geometry, okay? Now, next thing I'm going to do is send you the email with today's work on it. There is a reason why I'm not sending them early anymore. It's because people were kind of doing them early. And you thought, yeah, great video, what are you whinging about? People are doing your work early. Shut up and stop complaining. Fair shout, right? But I feel like people won't ask any questions then. And that's the point of the videos is that you get a chance to ask questions and raise up issues and be together as a class. And I mean, it's not just because I want you to kind of hear each other's questions, though that's good teaching. That, you know, you get questions, you get some answers. It's also like keep together as a group. Do you know what I mean? If we start falling apart as a group, if you get what I'm saying, it's going to be harder for you guys to kind of, you know, keep your like chins up and being positive, right? It's pretty rough. This whole situation for. So I'm going to do with you today, I'm going to send you today the calculus, the differentiation and integration. I think that's what we're doing today. If anyone wants to just challenge that quickly and says, actually, no, we're doing something else. The stream is lagging like crazy. Yeah, Wi-Fi has been a bit off. It's actually not my fault because you are not, I mean, there's 2 or 3 people who have the same problem. And I'm looking at the live and the live's working. It always lags about 20 seconds anyways. On Wednesday, what we'll do is we'll do the, we will do the Microsoft Teams so we can do Kahoots and things like that. So Wednesday will be a bit more fun. Today's very much a teaching lesson. Bloody hell, someone's having fun outside. So let me just reply to. So what I'm going to do is I'm going to send you the resources for today. What we're going to do is I want you to look through it with me now. And then, as we always do, whatever questions people want help on, that's fine. If you want to make sure that you're being registered, so you're on the register today, can you make sure that you are on the YouTube chat? I don't actually count. Like a load of people are responding on the, the thing. I've stopped doing that weeks ago, right? The main thing, the number one thing that you need to be doing is being on the live chat, because that's how I know that you're interacting with me. There are obvious exceptions. Like people have told me that their computers are down and it's, there's issues around computers. Fair shout, yeah, I get that. But if it's possible to be on the video at the same time, like a normal class, you need to do that. And send in a message saying, yeah, I was alive at, 3:04. Doesn't really tell me anything. All right, cool. So you should have now got an email. So check your emails for me. Okay, cool. While everyone's checking their emails and getting their stuff, hey guys, just going to do a quick recap of the news. So 3 big pieces of news well, 2 big pieces of news and 1 I've just sent you at work. The 2 big pieces of news are, number 1, the government are starting to talk about people coming back to schools. The first people are going back to schools are year 6s, and it looks like that's going to be around June the 1st. All right. Now, this is all subject to change. It's up in the air, etc. There's no guarantees this is what's going to happen, but that's what people are talking about. Okay. Immediately after that, so very, very soon after that, if that works, they want year 10s and year 12s to go. So that's you guys, right? So there is definitely an expectation, or at least a hope, that you guys will get some education this side of the summer holidays. And I'm all in favor of that. Which one? Both of them. Which one? So I'm just going to answer, sorry, that wasn't a very helpful answer to Jazir. Jazir says, which one do we do in the email? And my response is both of them. Okay? Both of them. Because differentiation and integration are fundamentally connected. To give you extra time to do that, your work is not due for the end of today, it's due for the end. Actually, it's due for Wednesday morning. All right, so for next lesson. Okay? So you will have more time to do it. So I'm not going to, the deadline isn't midnight tonight like it normally is. It's Wednesday, 9 o'clock. Okay? So give you a bit more time. Do yes, just to answer everyone's question, right? So yeah, just going back to the news, so you can expect, hopefully, I mean, unless there's a sudden uprising in cases, which could happen, or, lockdown is extended or whatever, you may assume that you might have a couple of weeks of classes. Okay? No problem. Now, number 1, that's number 1 piece of news. The second piece of news is, I completely forgot. It was 2 bits of things I needed to tell you. I told you that. I can't remember what was the other thing I was telling you about. That might be, if it comes to me, I'll let you know. You've now got your resources to start the lesson. Oh yeah, that was it. I've now started contacting parents for people that haven't come to lessons. And just to make it 1,000,000% clear, I actually don't really look at, when I send a message saying lesson started, I don't look at that anymore. I look at the live stream, because live stream means that you've contributed, you've said something in response to a question. All right. So most of them sending a message on, because I know you did it, so I'll pick on you. I'm not criticizing to say you did it. You put it on the thingy, but that's not what I'll look at. I'm going to look at the live chat. And I can see you said hi. All right, cool. So let me now shut up and give you a few minutes to look at the email that I sent you. What questions on there do you want help with? Same as it always is. All right. So it's the same format. This lesson is the same YouTube format. On Wednesday, we're going to go to a Microsoft Teams and do some cooks and do some other stuff, right? So I'm hanging around here for quite a while. What questions would you like to see? Scan both sheets. Don't just look at one sheet. Look at both sheets. Also, yeah, sorry, the other bit of news, I just remember what it was. I made a YouTube video for you for last lesson's work, all right? It's not a live stream, it's just a video, which you can watch, okay? And it's called Year 12 something or another. I can't check it now because I'm not on YouTube. Well, I'm streaming, but you know what I mean. So yeah, 1B differentiation. So shall it be, sir? Let me open that up right now. That's the kind of thing I'm looking to see from people. He's straight up, he wants this. And you know what makes my life super easy? I just need to find it and then we'll do it. Someone else has popped something out. I'll check that in just a second. I was going to pull up integration. I have got solutions for all these. I'll send them out at 4:30 as always. No, that's different. You want differentiation, not integration. Oh, kill me now. I've had enough. Actually, don't kill me now. That would be not a good idea. Let's have a look. Right here. So 1B. Oh, I see. I can see what you asked as well, to be fair. So we've got why equals. Let's just have a look at what other people are saying, and I'll launch into it. Question 2. Which one are you doing? We can start with whichever one you want, quite frankly, Rashid. I don't really mind. I would say look at both of them now, so you can ask me questions about both of them while I'm here. Do you know what I mean? This is your teaching time, isn't it? So let's use it productively. So differentiation 1 and 2. Okay, cool. Oh, that, yeah, I see both. I can see why you'd ask both questions, to be fair. Neither of those are stupid. What I'm going to do for the second one, I'm going to teach you some second year maths, because I think it's a good opportunity to do that. So y equals, for the first one, I'm going to teach you both times. Okay, let me ask you before I start doing anything. My dudes, would you prefer, and this is aimed at Jazir and Zeran, would you prefer I showed you how to do it first year style or second year style? Which one would you rather have? And what I'll do is I'll briefly demonstrate the one you don't choose for me to do. So if you say teach this first year style, okay, I'll just teach you first year style. If you choose to say second year style, I'll mention how to do it first year quickly, but then I'll show you second year style. Tausi, you're saying second, Kais, you're saying second, but Jazir and Zeran are the voices I'm looking to hear, yeah? Because it's their kind of questions. Because I'm more than happy, I'll give you a bit of a head start, whichever's easier. I mean, that's debatable, second year. Okay, fine, let's go with it. Right, okay, cool. When you've got a fraction, to differentiate, you can use something called the quotient rule. And I'm going to write it down for you, okay? Now, this is not unnecessary for this question. Like, because you can do this a year one method. You can do it like, sorry, I do apologize. You can use it with, you can do it, I won't say easier methods, this is, I think, quicker. Good to see you, my dude, Raha. It's been a long, long time. You have a lot of work to submit, all right? I need to catch hold of Sabarul as well. He's next on my kill list. So make sure you're getting your work done, all right? So the quotient rule says u dashed v minus v dashed u all over v squared. Where the hell did this come from? UV, what kind of garbage is this? Well, it's really simple, right? U is the thing that's at the top, otherwise known as a numerator. So 3 plus 2x, yeah? Now, u dashed, you know, hopefully you know from maths that dash just means differentiate. So 3 plus 2x differentiate is just 2, okay? V equals x root x, which is just x to the power half. And v dashed is, well, that differentiated. So half x to the minus a half. And then you just put these things into that formula. Game over, yeah? I'm not saying that that is the right, like the quotient rule is the fastest method to deal with that. It's just not. Well, it isn't really. But I've taught you a second year skill now. Do you get what I'm saying? And all you've got to remember is the numerator is u, the denominator is v, and the formula is u dash v minus v dash u over v squared. All right? Now, do you need to memorize it? Sadly so. Okay? Actually, I think it might be in the formula booklet. You might not even need to memorize it. Okay? So I'm just going to finish this off. I'm going to put the answer there. So u dashed v would be 2x to the half. Yep. V dashed u would be plus a half x to the minus a half 3x plus 2. So all I'm doing is timesing them. And I'll move that so you can see that a little bit more comfortably in just a second. All over v squared. Well, x to the half all squared, that'll just be x, wouldn't it, really? But, you know, I've written it out that way so you can see it. So that's what your final answer would look like, all right? Game over. Now, for this question, using the quotient rules actually makes it harder, all right? But the reason why I took the opportunity to teach it here was because you're going to need that skill so much next year. May as well give you a kind of introduction. So whenever you want to differentiate a fraction, you could use the quotient rule. The top one's called u, the second one's called v. U dashed v minus v dashed u over v squared, all right? So that's how you do the quotient rule, okay? Now, how would you do this in first year? And you're going to go, VJ, cringe, because it's so much easier doing the first year maths. But you get the reason why I taught you the second year, so you got a head start on it for next half term, really. So I'm going to rub this out now. I'm just going to do the question the old school way. This is the way you'd meant to be doing it first year. You'd go, okay, split this fraction in half. Well, not split in half, just, you know, break it into its constituent parts. So that's 3x to the minus a half plus 2x to the half. I hope no one's got any particular issue with that. I mean, I'm going to straighten that so you can see that a little bit better and move this along that way. Cool. Right, so this is that. And then differentiating that is relatively easy. And you're going to go, oh, VJ, that was, you know, it's ridiculous, isn't it, for me to do it the other way. they don't, well, you say, well, they don't equal each other either. They do, but you have to simplify it. 2 times a half is also just x to the minus a half. Okay, so that's the easy mode way of doing it. Now you might say, okay, what's the point of the quotient rule? Because not all fractions look like that. Yeah, not all fractions are going to be that simple. So for example, if you wanted to differentiate root x plus 3, that's impossible to do this way. You'd have to use the quotient rule there for that particular fraction. So the quotient rule works for any fraction. For this particular fraction, it's easier to do it this way. So that's one, I've taught you one of the 3 big rules already. Now the second big rule you're going to learn is something called the product rule. And the product rule is like an easier version of the quotient rule. In fact, they're related. I'm going to rub this out now. So for question 2, which is something that Zeron asked, question 2 says in differentiation, yeah, literally, I haven't forgotten, don't worry, this is literally what I was going to do, is that x equals 3u plus 2u squared minus 3. Okay? And what we're going to use here is something called the product rule. I'm going to show you the second year technique again first, and then I'll show you the first year technique. All right? Now, the product rule is very simple. It's u dash v plus, so not minus, v dash u. Okay? And the letters are not helpful here, so I'm going to change this into, let's go with this guy is a and that guy is b. So a dash b plus b dash a. Okay? But usually the product rule is written as u dash v, v dash u. They've just picked really awkward letters for the question, right? So product rule, a dash b, b dash a. So you pick one of the things that you're timesing by. And the thing about product rule is, quotient rule works as a fraction. Product rule works well amazingly enough when you've got product, when you've got 2 things timesing together. So here we've got 3 plus u timesing to u squared minus 3. That's the product of 2 brackets. The 2 brackets are getting multiplied together, right? So we're going to use the product rule, and we're going to call each bracket a name. We call one of them a, call one of them b, all right? So if a is 3 plus, so 3u plus 2, it follows that a dashed, which is just a differentiated, is 3. If you've got b as u squared minus 3, yeah, then obviously b dashed is going to be 2u. All right, just doing differentials. And then you just put them in the formula. So a dashed b, so you've got 3 lots of u squared minus 3 plus b dashed u. So 2u, 3u plus 2. Now you might be asking, oh, okay, that's the second year method. Very clever. Go you. Aren't you such a wonderful person? Well, I hope you're saying I'm a wonderful person. Can I just play around with, like, for a minute? Can I just beg your forgiveness? And seasickness is now going to come now, so I'm going to raise up the camera just so we can have a little bit more space. I'm kind of running out of space here. Right, cool. There we go. That should now work considerably better than it did. You're working out? No, I'm not. To be very. Oh yeah. What dx du? Yes. I'm working out the differential. Give me a minute. I'm trying to get this camera to show everything in one shot. That's being a pain in my neck. Yeah, that's fine. Nearly. Boom, that'll do. I'll move the camera. Boom. Yeah. Now I've got everything. So yeah. Basically, question 2 is literally say, can you differentiate this? And that's what I'm doing. And yes, it is dx du. So that's the second year method of doing what happens when you've got 2 things that times together, the product rule. Give each one a name, each bracket a name, call it AB, call it MN, you can call it whatever damn that you like, doesn't matter. And the formula is one of them dashed times the other one dashed times the first one. Yeah? So I always remember it's u dash v plus v dash u, because it helps me remember quotient rule as well. Because quotient rule is u dash v minus v dash u. And it's almost exactly the same formula. And in fact, when it gets to its second year, I'm going to show you how to prove them. But for now, all you need to know is what they are. So your question might be saying, okay, VJ, well, great. That's second year maths. Happy days. I think I understand that. Yeah, I mean, whoever that is, that last, the gentleman, I'm presuming is a gentleman. I'd be very impressed if it was a lady. Who are you? And why do you have such an inappropriate name in my chat? Right, anyways. Okay, so how do you do this normally without using second year content? You expand the brackets. You get 3u cubes, so this times this, minus 9u minus 2u squared minus 6. And you just differentiate piecewise, which is a flash way of saying you differentiate each bit by itself. So this will be 9u squared. Yeah. I mean, it's not very hard. And again, you might be questioning, well, why do I need all of these superpower methods? Because you're going to need them for harder math somewhere down the line. All right. So that's why I'm showing you them early. You know, you've seen them once. I think you saw them. You definitely saw chain rule as well with exponential. So I've gone on to second year content before. Okay. What else do people want to see? If the answer is not much, I'm still going to hang around here, so don't panic. Because, you know, obviously I think people need a bit of time to get a hang of what they're doing. Please have a look at the integration one as well. See if there's anything there you can't do. I mean, there are no problem. You don't have to thank me for doing my job. I appreciate the courtesy. So we have to Wednesday. Yes, you do. Absolutely. Because it's 2 worksheets. That's a fair amount. Hey, sorry, Satan. Yeah, of course. If you have technical problems, you have technical problems. These things happen. I mean, just do your best. Yeah. Number 5 in integration, please. And number 5 in differentiation. Although you got there slightly faster, so integration will start with. Rashida, just bear with me. I will do the question, obviously. I'm not going to not take the question, but he was there just a teensy bit quicker. Fine. Okay, now this is really interesting. The coordinate P is very, very simple to find. All right. So for 5a, first bit, incredibly simple. You just factorize. You go x squared out of that, and then go x minus 2. So you know that your equation is now this. So you should be able to just be able to look at that and go, okay, this must cut through the x-axis at 0. It must also cut through the x-axis at 2. Okay. Most of them, again, I think I'm satisfying both you and Omo on this one, your particular questions. That is, because part 5 is basically asking you, first of all, where does it cut the x-axis? It cuts it at 0 and 2. All right. How do I get that? I factorize and put it equal to 0. And that's how you find x-intercept. You put it equal to 0, put the equation equal to 0. Because if you think about it, when you cut the x-axis, y equals 0. So make y equals 0, factorize, solve that factorization, you've got the 2 intercepts, 0 and 2. So now the next question, you might think, well, this is incredibly easy. Just going to do this, aren't we? 2x cubed. And I mean, it is. It is. And it's a shaded area, so all you've got to do is make sure whatever answer comes out is positive. Okay? It won't be positive because you can see straight away that it's under the line as a number. So if you integrate this, you will get a negative number. All right? Is there an interest in seeing me integrate this? I'm more than happy to do it. It's a very, very simple question, right? But all you need to do is integrate this under bounds, between the bounds between 2 and 0, and you'll get the area. Okay, so let me just wait in the comments to see if people actually want me to do that. Can you second part? Yeah, okay, I'm just going to do it. So enough people are asking for me. Yeah, I'm going to do it now. Okay, fine. So what do you do first of all? You integrate, right? Yeah, of course. So that will be 1/4 x to the 4 minus, you bump it up, so minus 2/3 x cubed. Anyone want to check that I'm making mistakes or not? As I said, I'm quite sick today. So if I was going to do stupid things, this would be the day. I've already knocked over my camera once today. I mean, that shows what kind of day I'm having. Put 2 and 0 into there, okay? Now, this is going to be interesting because as I suspect, if the diagram is drawn correctly, and there's no reason to believe it isn't, that what you're going to do is you're going to get a negative number. Oh, Warren, I did not see that for question 3, so I'm definitely going to help you on question 3. So tell you what, I'll do 3 and 5 on differentiation as soon as I've done this. I didn't see that. No disrespect. Okay, cool. So let's pop 2 and 0 into here. So you've got 2 into there. 2 to the power 4 is 16. So that's literally just going to be 1/4 times 16. And then it's going to be minus 2/3 times 8. Okay. And now the other one will just be 0. Okay, it'll just be 0. Because you substitute 0 into any of that, you don't get anything out. So 1/16, so that's going to be 4, isn't it? Yeah. And then 2/3 of 8 is going to be minus 16 over 3, which is considerably, well, not considerably, marginally bigger than the other one. This will be 12 over 3, so what, 4 over 3? So negative 4 over 3. But what's your final answer? I will move the camera down so you can see that a little bit better. What is your final answer? The area is 4/3 because there's no such thing as a negative area. All right. So I hope that made sense to you. All I did was done the integration, corrected it for common sense. Like the idea of having negative 4/3 as an area, that's just not going to fly, is it? All right. So it's going to be positive 4/3. I hope that made sense to you. And it's there to warn you of something that happens in mathematics a fair bit, which is when they give you integration questions, the way they con you is to have some of it go under the graph. So how do you deal with that? How do you not get caught by that? You do it by drawing the picture every single time. All right. Cool. So question 3 and question 5 on differentiation, unless anyone's got a problem with that. If you do have a problem with that, put it in the comments, put it in the live chat. Don't put anything in the comments, so I'll never see it. I literally never read my comments are full of like random spammers saying let's team up, and they're like, I don't know, Fortnite players, and it's like, it's a math channel. You're clearly a spammer. Right, okay, cool. Back to actual life rather than Fortnite. Okay, so curve has find the equation of the tangent to the curve. Okay, cool. All right. So this again goes back to what we covered last lesson. That's why we're doing these things in this order, right? Equation of tangent. So the gradient of tangent is the same as the gradient curve. Yeah, that's the definition of a tangent, is that it touches only at one point and it has the same gradient as the curve at that point. So what first thing we need to do is differentiate and work out what the gradient of the curve is. Then once you've worked out the gradient of the curve, then you'll be able to say, well, that's going to be the same as the tangent. All right. So let's differentiate right now. So y equals 2x cubed minus 3x squared minus 8x plus 9. Now, if you differentiate that dy dx, of course, we'll come into the situation. That's going to be 6x squared minus 6x minus 8. And that's your differential. And that's all there is. Nothing else. Dy dx is that. Are you happy with that? So once I've done that, what I'm going to do is I'm going to substitute in 2. Why? Because I want to know the gradient at 2. So therefore, what have you got here? You've got 24, because 2 squared is 4, minus 12 minus 8. And that equals positive 4. Now, I don't need to do anything about negative reciprocals. Yeah? I do not need to do even the slightest thing, because here it's a tangent, not a perpendicular. It's not a normal. Okay? So y equals 4x plus c. How would I find c? Then I would need to be able to just substitute in the coordinate. So minus 3 equals, what is it going to be? 4 times 2, which is 8 plus c. So c must be minus 11. I hope that makes sense to you for part 1. All right? So that's part 1 of question 3. Don't worry, Rashida. I'm going to get to question 5. That's going to happen. I'm going to give you a few seconds just to get that noted down. And remember, you can watch the video again. It usually takes a few hours to upload, though. That's one of the awkward things about YouTubing from your house. I mean, I don't know if it's a bandwidth thing or what, but, you know, it will usually turn up like the end of the day or the next day. Okay, cool. So I'm hoping that made sense. Differentiated to find the gradient of the curve. The gradient of the curve is the gradient of the tangent. Y equals 4x plus c. Put the coordinate, game over. All right? Part B. Or part 2, rather, because they use the Latin numbers, don't they? They say, find the equation of a point Q where the tangent is parallel to the tangent of P. So I was a little bit hasty there, because the equation I'm going to have to do is do dy dx. Oh, you've already got dy dx, I hope. I'm going to recreate it anyways. And so dy dx, what was that? 6x squared, 6x minus 8 is equal to whatever we decided was the gradient of the tangent. So that was, what was it, 4? So what we need to do is solve this equation. It's just a simple quadratic. Remember, your calculator is more than equipped to do that for you. So that's the equation you need to solve. Obviously, you'd have to rewrite it like this, wouldn't you? And I mean, I'll make your life a little bit easier. I'll divide 3 by 6 at that point. Just go x squared minus x minus 2 equals 0. And that's a very, very simple quadratic to solve. That will give you the x coordinate. All right. Once you've got the x coordinate, substitute back into the original equation, not the dy dx, the original equation, to get the y coordinate that goes with the x coordinate. So you solve this. One of your answers will be 2. Yeah. The other answer, you take and you substitute back into the y equation. I'm sorry. Yeah, the equation is the y equation. The equation goes y equals stuff, and that will give you the y coordinate. The reason why we disregard the 2 is we already know about the 2. The 2 was 2 minus 3. That's a coordinate we're already familiar with. All right. So I hope that made sense for question 3. Why is it equal to 4? Okay, the reason why it's equal to 4 is if you substitute 2 in there, that's what you get. So if you substitute 2, which they told us that's the coordinate of it, 2 squared is 4. 4 times 6 is 24. 24 minus 12 is 12. 12 minus 8 is 4. Yeah? So all I did was I found out that the gradient has to be at x equals 2, dy dx equals 4. All right? Don't worry about that. Can you? Yes, of course you can. That's always true. And I mean, that might make sense. I was like, hang around for a bit. I mean, just check your emails stuff, because then you're still in a position to ask me questions, right? You watch it again from the beginning, yeah, by all means, but just don't do it right this second. Use the time to have a look at the questions that, oh my God, I can't do this, I need help with. Yeah. And if it is something I've already done a question of, then I'll say, you know what, rewind, it's there for you. All right. Okay, cool. So I promised Rashida 5, so I'll do 5. Anyone else want any other particular questions? Pop it in the live chat. I'm listening. Yeah. So what's 5 like? Okay, where does this curve cross the x-axis? Well, you make y equals 0 and you solve. Okay, simple as that. Differentiate it once, hence find the stationary point. Oh, I see. I mean, it might be worth me just doing this, I think. If you've got y equals 2x cubed minus 6x. First things first, I'm just going to factorize that. Factorize 2x out of there, and you get x squared minus 3. Okay, so that's your equation. Okay. What are my 2 solutions there? Well, I've got 3 solutions actually. X equals 0. So when I say solutions, what solutions to this equation? 2x, x squared minus 3 equals 0. So we're going to put 0, put that equal to 0. That's what we're doing, right? So that happens when x equals 0, or x squared minus 3 equals 0. So x equals plus or minus root 3. Okay, so those are your 3 solutions for where it crosses the x-axis. It crosses the x-axis at 0 and at plus or minus root 3. Don't know where in plus or minus root 3, but there. I hope that's making sense to you. So that's hopefully not too bad. I think. That's a relatively simple question. So it says find dy dx. Okay, that's easy enough. Dy dx is pretty simple. Dy dx equals 6x squared minus 6. If you want to find stationary points, guess what? You make dy dx equals 0. So this is the equation you solve. 6x squared minus 6 equals 0. So divide through by 6, you've got x squared minus 1 equals 0. X equals plus or minus 1. Yeah? So dy dx has stationary points at plus or minus 1. So those are your 2 stationary points, right? The next thing you do is say differentiate it a second time. So d2y over dx squared. Great. And that gives you 12x. And what you've got to do is substitute each one of these in and use the rules. Now, what are the rules? If d2y over dx squared is larger than 0, then you've got a minimum. And if it's less than 0, you've got a maximum. I'm not sure you can see that, so I'm just going to check the video and see if you can or not. No, you can't. You can't. Okay, so I'm just going to drag. In fact, if I'll just pull up the plastic sheet, that might help a little bit. So yeah, a bit more than that, I think. A little bit more. Thank you. Don't worry, I'm sorting this. I see this is a problem. There we go. Okay, cool. So that's, I think you've got all of the question practically. I'll move that up to teensy bit. Just about. There we go. Okay. That's about as good as I think we're getting. So, what have you got there? You start by working out where it cuts the x-axis. How do you do that? Make it equal 0. Nice and simple. Yeah, plus or minus root 3. And 0. Those are your 3 solutions to that equation. Then you differentiate, put that equal to 0. What does that get you? It gets you the turning points. Once you've got the turning points, you differentiate a second time and you substitute in the values into your second differential to make a decision whether they're minima or maximum. Minimum point or maximum point. So you've got 1 minimum, 1 maximum. And that's your lot. That's all that question is. And it's all basically around the idea of when you put certain things, sorry, I'll hand over a list there. When you put certain things equal to 0, what are you getting, right? So if you put y equals 0, you're getting x-intercept. If you put dy dx equals 0, you're getting turning points. Now, with d2y over dx squared, you don't put it equal to 0. What you do is you substitute your turning points into that one to find out what flavor of turning point have you got. Have you got a minimum? Have you got a maximum? All right? I'm starting to see people drift away, which means that they're ready to work, and that's awesome. That's my elbow. I'm going to hang around here for maybe another 3 to 4 minutes. If anyone particularly needs any help, let me know. And if people decide they don't need any help, I say 40. That's. Could you help me with a different question from the past paper pack you've got? Yes, I could. I mean, your best option is to send me a picture of it. Rashida, no problem, of course, at any time. Fazana, same to you. Sorry, not same to you. Thank you. No, you don't need to thank me, but I appreciate the thought. Yeah, Kelsey, if you've got individuals different questions, by all means ask them. If you send a picture on Teams and say the next, say 5 minutes, I'll do it. If you don't, what I'll do is I'll start my next lesson with it. Either way, all right? You'll definitely get it. So if you can do it now, that'll be awesome. Is it both? Yeah. Just so you know, Dawit, it's not due for midnight tonight. It's due for Wednesday, 9 a.m. So you've got 2 days instead of 1 day to cover it all. That's why, you have got more work. So I thought, let me give you more time. Anything you can send me early, though, it's grateful because I mean, I don't have to check anything. So yeah, the answer is yes, it's both, but it's not both today. It's both from 9 a.m. tomorrow. I'm hanging around here for about another 4 to 5 minutes, just to give you a heads up. So Jacob, no problem. It's a pleasure as always. Thank you for popping up, and it really does help. So try to avoid working out fine borders. Let's have a look, see what we've got. Bloody hell. Oh, this guy. No. Okay, cool. Let me show you that. So you already know that the integral for root x, I don't know, I haven't looked at it. The integral for root x is a. I'm going to say to you that this is a true statement, that a to the 1 root 8x is the same as root 8 to the a to the 1 x. I hope that makes sense to you. Do you agree with that for a start? 5 the first sheet, I'll go back. That's a video that's been done. That's done on the video, Dawit. Second sheet, maybe. Let me just check what that is. I think I've done that too, but if not, I'll definitely do it for you. So presumably you're talking about integration at that point. 5b, yeah. Again, go back in the video, you'll be able to see that. You don't understand that? Okay, cool. It's something we're familiar with. If I said to you that the integral of 3x is the same as the integral of 3, you can take the number on the outside. That's all I've done, yeah? Is that something you're familiar with? If not, I've just taught you something. You get what I'm saying? Because like if you've got an integral, you can take a constant. What you can't do is this. That's not allowed because x isn't a constant, it's variable. All right. So all we're going to say there is that your answer should be 10 root 8. Well, now you do. Okay, cool. So just by looking at that, the answer to AI should be 10 root 8. Or at worst case scenario, root 800. Is that what the mark scheme's got? So I can't see the mark scheme. (32/3). Really? Send me a picture of that as well. Show me some of the mark scheme. What I told you is certainly true, by the way. So send me a picture of the mark schemes, that might help. As for the second part of that, the answer is just going to be literally 10 plus whatever the integral between 1 and 0 of root x is. So do that second part. We're just trying to save some time here. Show that a equals 2k. What you do is you're going to get Probably the easiest way to do it, just do the integral hard and fast and go, okay, that's a, that's 1, that's root x, and that equals 10, and solve that as an equation. So the way that would go would be that's just going to be x to, it's x to the half, isn't it? So you up it x 3 halves. And then what are you dividing through? So 2/3. Then I'll ask him, let's have a look and see if that showed up. I mean, I'm not sure that that's, I think it's missed out one of the answers. That's what the problem is. I think this one, the one we're going to do, like for the other one, if you do that, I think that might be 32/3. In fact, let's just prove that that is 32/3. That's going to be x to the 3 halves, so 2/3. Yeah, that's what it is. So it's not, yeah. And so the mark scheme is referring to the second question in 8a. That's the problem. And that answer to that is 32/3. Yeah. So it's not that it's wrong. However, the one we did was also right. It's just the mark scheme hasn't got an answer for it, but it is right. Okay. So just on the third one, let's just finish off this guy. I've lost your question now. Oh, here it is. I'm going to knock this one off now. Where was I doing? I was used like this was this one now. So then you go, okay, fine. We know between a and 1 of root x equals 10. We know that's a true statement. We integrate this. We're going to get x to the 3 halves times by 2/3 between a and 1, and that equals 10. So that's going to give us what? You substitute the a into that, you're going to get 2/3 a to the 3 halves minus 2/3 equals 10. Yeah? I hope that makes sense. As long as I've got, yeah, I have got that right. Yup, and then divide by power. So divide by, yeah, that's fine. So we've got a 3 halves equals minus 1, equal, factorizing out the 2/3 equals 10. Dividing through, so that's going to be what, 30. So we've got a 3 halves minus 1. Dividing by 2/3 the same as times by 3 halves. So that's going to be 15. A 3 halves equals 16. So a, I've already answered the question, haven't I? But now we can work out exactly what a is. Square root both sides. You can't see any of this, can you? You can't see this. I'm going to move this on now. I'm going to move it back there so you can see the rest of it. So square both sides and you get a cubed equals 256. So what cubed? Is it 864? No, it's not. It's 4. Is that really right? 16 squared is 256. I'm just checking if I made any mistakes. A cubed, yeah, a cubed is 256. So what cubed? 4, 16, 64. 8, 64, that's 2, 5, 12. That's annoying. I mean, what you're going to do is you're going to work out what number this is. There's a better way of doing that. So you've got a cubed is, yeah, you need to find out what a is. I know 256 doesn't cube, is a bit annoying. Cube root 16 squared, yeah, but I agree, it is cube root 16 squared. Give me a minute, I'm going to figure this out. It shouldn't take too long. It's a decimal. Yeah, but I don't want the decimal if I can avoid it. I'll take a fraction if I have to, though. I'm trying to avoid a decimal. Yeah, I'm not interested in any 6.3. 6.3 can look after itself. I'm going to stick with this guy here. So this is, so how would I get rid of this? I'd square both sides. I'll go a equals, yeah, I've got a cubed equals 256. So yeah, a equals the cube root of 256. So that's 256 to 1/3. What is 2 as a power? 2, 4, 8, 16, 32, 64, 128, 258, isn't it? So 8 equals 8/3. Yeah. I'm going to go with that. 256, 8/3. So 2 to the 8/3. Yep. That's where I'm going with this. So what I'm saying is 256 is 2, 4, 8, 16, 32, 64, 128, 256. So 2 to the power 8 is 256. So I can go 2 to the power 8 to the 1/3, which is 2 to the 8/3. And that's your final answer. I hope that makes sense to you. And that's that done. All right? So that's the way you do it. Because I don't want, the decimal's not necessary. You don't want the decimal at all. All right? So I hope that now makes sense to you. I got it to this point here, and then I turned this into power of 2. All right? Seems like that's okay. I don't think anyone else has got any questions. If they do, let me just quickly run through the video. I'm just going back up the chat, see if anyone's got any questions. Now it seems to have found it, I think. If anyone's got any particular issues, let me know. Yeah? There we go. Right, cool. I think I'm off now then. If anyone, yeah, again, just bring back questions for next lesson. There's no rush for this. You know what I mean? You've got till Wednesday at 9 a.m. Take care. Bye.